Good afternoon, all my dear students. Today we go for starting our unit 4, that is S block elements. The unit 4 consists of two parts, the S block elements and the P block elements. So here I brought you in front of all the lecture on S block elements. So in this lecture, we are going to learn the introduction of the S-block elements, their important physical properties, specifically like atomic size, ionic radii, ionization energy. Some of the properties we have learned in the second unit. What's the property meaning in the periodic table? So specifically for the S block elements, we learn its physical properties. Then we go for its chemical properties and the very important relationship we have to see in the S block element, that is diagonal relationship of the elements. What is the learning outcome of this unit? The students are able to understand the S block elements in the periodic table very detailing. Its physical properties, how they go for understanding about atomic size, ionic radii, as well as their chemical properties with all the reactions involved and the diagonal relationship. So you are able to understand all these things, complete detail of the S block elements. So which elements are considered to be S block elements? In the periodic table, it consists of two groups, the one and the second. The group 1 and the group 2 are the S block elements. Why they classified as the S block elements? Because how we go for classification in the periodic table like S, P, D, F block elements according to the electronic configuration. If the valence electron of any element enters into the S subshell or the orbital, the valence electron, that is outermost electron. If the outermost electron goes to the S subshell or the orbital, it is considered to be the S block elements. And if the last or a valence electron enters to the P subshell or the orbital, are considered as the P block elements. And if the last electron or the valence electron enters to the D subshell or the orbital, it is considered as a D block elements. And if the last electron enters to the F subshell, goes to the F block element. This is the classification on the basis of electronic configuration. So the last electron enters to which subshell is on the basis of that we can understand whether they are S block, P block, D block or F block elements. So in the S block elements, the last electron is filled in the valence S orbital having the electronic configuration ns1 and ns2. Extreme left part of the periodic table starting from group 1 and group 2 are considered as the S block elements. The first group elements contain 6 elements: lithium, sodium, potassium, rubidium, cesium and francium. Which is having the electronic configuration, you can understand it comes in the S orbital, that is ns1, and they are called alkali metals. The second groups contain beryllium, magnesium, calcium, strontium, barium, radium. having the electronic configuration Ns2. The inert gas in the bracket is showing rest of the electrons are according to the electronic configuration of the inert gas. So mainly the outermost electron we are seeing in Ns1 and Ns2. They are called, the group 2 elements are called alkaline earth metals because their oxides are alkaline in nature, basic in nature. That's why the name given to alkali and alkaline. Earth metals means they are found in the earth crust. So group 1 alkali metals, group 2 alkaline earth metals. Now we come to understand its physical property. When we are able to understand which, having according to the electronic configuration, there is block elements, and group 1 and group 2 come under this category. So let's see its physical property. The first is atomic radii. We have learned this property. The distance of the nucleus to the outermost electron is called the atomic radii or atomic size. We have learned this, and we have learned the trend also. In moving left to right, the atomic radii goes on decreasing because of the effective nuclear charge increasing. And down the group from top to the bottom, atomic radii goes on increasing because the number of shells goes on increasing, and it is due to the screening effect. The atomic radii or the size goes on increasing. So here in the alkali metals, when we talk about group 1, it increases down the group, and in the alkaline earth metals also we have a group 2 which is also increases down the group. And as anybody asks, what is the relationship of the atomic radii of alkali and alkaline earth metals? So if we compare the alkali and alkaline earth metals atomic radii, so atomic radii of the alkali metal is greater than the alkaline earth metal because from left to right it goes on decreasing. So alkaline earth metal is having a lesser size than the alkali metals. So here is the example: sodium and magnesium. Sodium is an alkali metal and magnesium is a alkaline earth metal. So the atomic size of sodium is greater than the magnesium. So that is the one of the property we can able to understand. The next is ionic radii, means how easily the metals goes of forming the ions. So again, if we talk about the radii among the alkali metals down the group, the atomic radii, like it goes on increasing, the ionic radii also goes on increasing down the group. And alkaline earth metals also down the group and ionic radii increases. And if we compare both alkali and alkaline earth metal, ionic radii decreases. Means alkali metal have the high ionic radii than the alkaline earth metals. So ionic radii and the atomic radii has the same reason of down the group or period left to right. The third comes valency. How easily the electron removes from the metal, it causes its valency. So the alkali metals are monovalent, means it can lose one electron. They are monovalent, and alkaline earth metals are divalent. They have the ability to lose two electrons. That's why they are divalent, and alkali metals are monovalent. So next we talk about the property ionization energy. Is the energy released to remove an electron from a gaseous atom. So from left to right, ionization energy goes on increasing because of the atomic size goes on decreasing. So it is very difficult to remove an electron when we go for left to right or atomic size decreases, and down the group ionization energy decreases. So here you can see down the group ionization energy decreases means in the alkali metal we can see lithium has the higher ionization energy than sodium, potassium, rubidium, cesium and francium. And in alkaline earth metals also we can see beryllium is having the high ionization energy, then magnesium, calcium, strontium, barium and radium. So the same concept of the ionization energy we can use in the S block in the alkali and the alkaline metal, earth metals. The next is physical state. If we see in a which state or in which color it should be present, so alkali metals are silvery white in color. These are very soft metals, so they can be cut with the plastic knife. We can cut the sodium, potassium, they are very soft metals, so they can be cut with the plastic knife. Whereas the alkaline earth metals are silvery. It's not whitish in appearance, but they are silvery. These are also soft but harder than the alkali metals. As we compare with the alkali metals, they are harder than the alkali metals, but they are almost with the other elements, they are softer. So that is the physical state. The next property is metallic character. You know the tendency of losing the electron. How the electron can be lost by the metal very easily. That is the tendency is called metallic character. So metallic character is directly proportional to the size of the atom. If the smaller size of the atom it is there, the nucleus is holding the electron very strongly. And if it is of a bigger size, nucleus do not hold as strongly as in the smaller size atom. So in the large size, the tendency of losing the electron become high. So that's why higher the size, metallic character is also higher. That's why metallic character is directly proportional to the size. Understood? Means smaller size, the holding capability of nucleus to the electron is very strong. So it do not allow the electron to go. But in bigger size, that holding capacity decreases so that the electron can be easily removed. That's why it is directly proportional to the size. So metallic character increases down the group because in the group atomic size goes on increasing. So we can understand with the size the metallic character. And if we compare alkali metal to the alkaline earth metal, then alkali metals are more metallic than the alkaline earth metals because the size of the alkaline earth metal is less than the alkali metals. The metallic character of sodium is greater than magnesium. The next property, physical property, is boiling point and melting point. The boiling point and melting point also depends on the metallic bonding. The metals force of attraction, metallic bonding, you have read in the metals it is formed. So metallic bonding depends on number of valence electron, how much number of valence of electron are there and their size. The metallic bonding is directly proportional to the valence electron and inversely proportional to the atomic size. So we can easily understand that it is inversely proportional to atomic size means if we see in the group the atomic size goes on increasing. So when atomic size goes on increasing, their metallic bonding goes on decreasing. They are inversely proportional. So metallic bonding decreases means boiling point and melting point is also decreases. So you have to remember how we determine the boiling point and melting point by determination of its metallic bonding, which depends on either the valence electron, number of valence electron, or the atomic size. The next property is density. The density is equal to mass upon volume. So alkaline earth metals are more denser than the alkali. Why? Because as you see, sodium is an alkali metal and magnesium is a alkaline earth metal. Sodium has the atomic number 11. Magnesium is having the atomic number 12. And if we see their mass, atomic mass of sodium is 23 and atomic mass of magnesium 24. So the mass is greater of magnesium. So as you have seen, density is equal to mass upon volume. It is directly proportional to the mass. So mass is greater, the density is greater. So here you can see in the group we have more mass. So lithium, then we have potassium, then we have sodium, rubidium, cesium and francium. Francium is more denser. It is higher denser metal in the alkali metals. So here you can have the underlying elements potassium and sodium, because the sodium should come first and potassium should come after the sodium according to the elements of the alkali metals. But there is the exception. Exception in the case of density, the potassium is having the lesser density than the sodium. So this is the exception in the alkali metal found. Down the group, density goes on increasing, but potassium and sodium goes for interchanging. In alkaline earth metal, also there is an exception. Beryllium is having the more density than the calcium, magnesium. So the order of density is goes on exception in the case of alkaline earth metal also. Thank you. In the next lecture, we continue more chemical properties of the S block elements. Till then, goodbye.